In this presentation, I want to talk about data presentation in statistics. Essentially, statistics cover the aspect of data collection, data sorting, data management, data analysis, and data presentation and interpretation. So today we are going to focus on data presentation. So again, statistics involve collection and presentation. Broadly speaking, statistics can be viewed as a discipline where we manage data generally for the purpose of understanding our population. Sometimes you want to study 100 patients in a study, maybe you are looking at their weights, and you want to have a picture of how this particular variable or data in that population actually flow in terms of pattern. So, broadly speaking, statistics can be divided into two groups, the descriptive and the inferential. The descriptive aspects include the univariate, bivariate, and the multivariate presentation of data. While inferential statistics looks at the different way of comparing mean or comparing variables. So we look at statistical description of data. There are two possible ways data can be described in statistics. For the numeric set of data, we describe them by center, variability, and shape. While the categorical set of data, we describe them based on frequency, percentage, or proportion of each category. Now let's look at the contrast between the word data and variable. It's important to understand that when information is obtained from the subject of a population, that piece of information is described as data. Now, if that piece of information differs from one subject to another, we describe it as a variable. So, a clear understanding of the difference between a variable and data implies that all variables are data, but all data are not variables. In other words, certain data may remain constant for every subject in the population, while some others piece of information might change from one subject of a population to another subject of a population. Now again, we define a variable as any characteristic of an individual or entity. It is essentially the condition or certain condition of the subject of our population that may actually take different value, and which is our interest in studying in statistics. So most researchers begin with a general question about the relationship between variables. So in terms of relationship, you can look at the relationship between the class size and academic performance. So you can look at if the class size actually affects academic performance. In this case, the class size becomes our independent variable, while academic performance becomes our dependent variable. Again, variable can of course be measured on different scales. We have the nominal scale, we have the ordinal scale, we have the interval scale, and the ratio scale. The nominal scale of measuring variable is the identity form of measuring variable. In this case, we are only trying to identify the variable. It does not really describe the magnitude of that particular variable. For instance, you talk about the name of an individual, the gender of an individual, the complexion. These are examples of variables that are measured on nominal scale. While the ordinal scale talks about the ranking of variables. You think of the severity of a condition, you think of a grade, you think of a grade of a class or level, or you talk about category, cadre. These are other kind of variables. And again, we have the interval kind of scale of measuring variables. Of course, this one is similar to the ordinal scale of measurement, but the 0 point is considered arbitrary. An example is our temperature that is measured in Fahrenheit scale, and of course our calendar. Okay, so these are examples of the interval scale for measuring variable. For interval scale, addition and subtraction are meaningful, but multiplication and division are not meaningful in interval scale of measurement. While for the ratio scale, variables with all property of interval scale is present, but non-arbitrary 0 point is usually a common property of the ratio scale of measurement, like age. You cannot have somebody having age of -1 or weight of -0. So we describe that as a ratio scale of measuring variable. Okay. Now let's look at a few definitions about a data set. A data set may be said to be unimodal. In other words, it has just one mode. In other words, a particular observation has the highest number of occurrences. And when you have two observations with same highest number of occurrences, we say it's bimodal. And you can also talk about the symmetry of a data set. Okay, you want to look at one side of the curve of that data set. Is it symmetrical with the other side of the data set? Now, in data presentation, data can be presented in frequency table. Usually when data is collected raw, say you gather information about 26 children, maybe between the age of 1 and 6, and then you want to come up with the frequency of their age, and you put it in form of table. We describe this as frequency distribution table of the age. Now, sometimes you may also want to group this particular age. Maybe you want to put them in different classes. That is a group frequency distribution table. And sometimes you may also want to have a cumulative frequency table. In this case, you are trying to have a multiplier effect of the frequency, or an increasing additional effect of the frequency. So it means that for the first column, the frequency is 5, and then your cumulative frequency will be 5. But for the second column, where you have the frequency to be 3, your cumulative frequency is going to add up the initial 5 with the next 3 to get 8. So that is how we plot our cumulative frequency table. Same thing applies to a group frequency, cumulative frequency table. Now, still on data presentation, data can be presented graphically, just like we have on the slide. And presenting data graphically helps us to easily appreciate the pattern of spread of the observation within that particular data set. We can easily spot an outlier when we present data graphically. You can see the example of an outlier. An outlier is an extreme value that falls completely outside the overall pattern of our data set. So we present graphically so that we can have a clear overview of our data set. Now, bar diagram and pie charts are usually used for categorical variables, while our histogram, the stem and leaf, and the box plot are used for our numeric variables. Okay. Now, in terms of categorical variable, we have the bar chart, like I mentioned earlier. You have the treatment group. The first thing to do is that you must first of all come up with the table where you are going to come up with the frequency. You calculate, you compute for the proportion or the percentage, and that is what you will use to plot your bar diagram. While for the categorical variable still, the pie charts, you use that same table to prepare your pie charts in form of sector. Okay. Now, while for the numeric variable, you use your histogram. This is an example of a histogram. Okay. The histogram will give you a stack of bars that are connected with one another. And this, importantly, is used for presenting our continuous variable. Okay. And again, we can as well use our box plot. The box plot is a 5-number summary presentation of data set, where you have the first quarter, you have the third quarter, you have the minimum, you have the maximum, and you have the median. So this is a typical way of also presenting our numeric variable. Now, numeric variable, usually we measure what we call central tendency in our numeric variable. And this is very, very fundamental to statistics. In measuring central tendency, the idea is to use a single value to represent a data set. For instance, if you have a classroom, a particular class or a particular grade, we want to tell what is the average age of that particular class. So that average age becomes a reference point for that particular class. So that is the concept of measure of central tendency. Now, the example on the slide shows two data sets. The first data set has 30, 50, and 70, while the second data set has 40, 60, 50, and 60. Now, the question here is, which measure of central tendency best represents each of the data sets? Again, our measure of central tendency are the mean, the median, and our mode. But depending on the type of data set we have, it will determine the one of these three mentioned measure of central tendency that can best represent each of the data sets. Now, if you look at the first data set, you will discover that the mean of the first data set is 50, and the mean of the second data set is also 50. But the question is, which of the data sets does the mean perfectly represent? And of course, that is the second data set, because the data here in the second data set are a little bit closely packed. So if 50 is used to represent them, it gives a very perfect representation. So the implication of this is that when the data set is dispersed, okay, the mean will not be the best measure of central tendency. Let's have a definition of what our mean tries to explain. Our mean is the average of the individual variables within our data set. When you have your data set and you add individual variables and you divide it by the number of variables, that is the summation x over n. That gives us our mean. While of course our median is the value that occupies the middle value. Okay, for an even number of data sets, we are likely going to have two values at the middle. In that case, to calculate the median, we are going to divide those two middle values to get your median. While the mode is the value that of course has the highest frequency of occurrence. Okay, but one thing is important about mode. The mode is undefined for sequences. The mode is undefined for sequences in which no observation is repeated. For instance, when you have a data set and none of the observation is repeated, we say the mode is undefined. Okay, but it's important to understand that mode is a good measure of central tendency. More often, people don't use the mode. Okay, so but what you main major determinant of our measure of central tendency? In other words, which of these three measures of central tendency is best suited for a data set? How do we determine? Number one, we look at the dispersion, that is the spread. How scattered are the observations within that data set? And that is the example I gave about those two different data sets, where 50 better represents one over the other one. So we look at the dispersion of the data set. We also look at the skewness. What does skewness mean? It talks about how drifted that particular curve obtained from that data set is. The data we obtain, we can plot it on the curve. When we plot it on the curve we give a shape that give an insight to that particular data set. When you have too much extreme value, the data set is going to be tilted towards the side of the extreme value. So when you have a positively skewed data set or a negatively skewed data set, the mean is not a good representation of such data set. But when you have a symmetric data set with zero skewness, the mean is appropriate for representing that data set. Okay, so again, we say the mean is less sensitive to outliers. When you have outliers in a data set, what's an outlier? An outlier is an extreme value. Okay, when you have a class of an average of, maybe the average age of that class is supposed to be 25 years old. But here we have a man of 65-year-old being enlisted into that class. That man with his age is an outlier in that particular class. So, and the median is less sensitive to outlier, but the mean is very, very sensitive to an outlier. So the median is better measured than the mean for a highly skewed distribution. Like when you see the example on the screen, you have a data set where you have 20, 30, 40, and 990. Now, if you find the average of this data set, you are going to get 270. While on the other hand, if you discover that this 270 as the mean does not typically represent this particular data set. But if you find the median will give us 35, which is a true representation of this data set. So the mean 270 really fails to give a realistic picture of the major part of this data set because it is influenced by this extreme value, which is 990. Now again, we talk about measuring variability in the data set. How do we measure variability in the data set? Now we have the commonly used method is use of range, your variance, standard deviation, interquartile range, and coefficient of variation. Now the range is usually the difference between the largest and the smallest observation within our data set. So when you have a data set like this, as we have on the slide, you pick the highest value, you subtract the smallest value from it, and then you get your range. But it's important to quickly state that the range is a good measure of variability. More often, range is never used to measure variability in a data set. So, but more often, we also talk about variance of a data set. The variance of a data set is the average of the square or the deviation of the individual observation from the mean within that particular data set. So when you pick each individual observation and you subtract the mean from it, it tells you how the data set, the individual data set, is scattered from one another. So in the case of the example on the slide, you can calculate your variance by finding the difference between the mean and individual observation, and you square each of those differences, and then you divide it by n-1. More importantly, when you are handling a sample. So our variance is going to be equal to 4. Now the standard deviation is the square root of this particular variance that we have calculated. Then we go to the next measure of variability, which is our quartile. Our quartile is obtained by dividing our data set into 4 regions using the projected formula. n-1 divided by 4 will give us our quartile. And then we have what we call the first quartile, which is the 25% of our data. And then we have the second quartile, which will be 50%. And the third quartile will be 75%. So quartile is another measure of an important measure of variability. So how do we calculate it? We have an example here, 15 plus 1, which is the number of our data sets here, divided by 4. That will give us the first quartile, okay, which is equal to what? Which is equals to 11. And then the second quartile will be 40. The third quartile will be 61. So you can have the first quartile 11, second quartile 40, and the third quartile is 61. And then we can begin to talk of interquartile range. The interquartile range is the difference between the third quartile and the first quartile. Then we talk about the decile. The decile is obtained by dividing our data set into 10 parts. Okay, we mark up the 10 points, the 10 parts as cutoff. So dividing essentially by 9 rulers, it will divide our data set into 10 parts. And the formula is as projected on the slide. n plus 1 divided by 100. similar to what we did for quartile. Now we can calculate what we call coefficient of variation. So we'll talk about percentile, we'll talk about decile. Okay, decile is dividing into 10, percentile is dividing into 100. Now we're going to conclude this presentation by talking about coefficient of variation. Now, what is the importance of coefficient of variation? More often when we look at a data set, we talk of the variation of the observation within a data set. But at times when we want to compare two data sets, we cannot actually compare their mean. It will not give us a realistic comparison between two data sets, but we can compare the coefficient of variation of two data sets. Now, comparing the coefficient of variation of two data sets gives us a clear reality between the variance or the variation between two data sets. Okay, so again, we have what we call the 5-member summary of a data set. I mentioned it earlier on, like our box plot is an example of a 5 summary of our data set. This will involve plotting our graph using our 5 summary. We have the first quartile as we have obtained in the previous slide, and the third quartile, the minimum, the maximum, and also we have the middle number, okay, to plot our box plot. So this is an example of our box plot talking about the distribution of age in months. So you have the median, you have the maximum, and the minimum. That is what we use to plot this particular box. Okay, the first quartile will be this point, the minimum, the first quartile will be this lowest point, the minimum will be this point, and the median will be this yellow point. And then you are going to have the maximum before the third quarter. So when we spot this point and we join the line together, we have what we call our box plot. So when we choose a summary, it's important we look at the shape of our distribution. In summary, we look at the shape of our distribution. We look at the skewness of our distribution. We look at the dispersion of the individual variables or observation within that particular distribution. This is very important in guiding us to know the best way to present our data sets. Again, the shape of the data is important, the skewness, the kurtosis. Okay. Again, we talk about the measure of asymmetry of the data. How drifted is the data set? Okay, you can have a positive or rightly skewed data set. If your data set is bent towards the right hand side here, we say it is positively skewed. If your data set is bent towards the left hand side here, we say it's negatively or left skewed. So you're going to have a longer left tail for a negatively skewed, while you're going to have a longer right tail for a positively skewed data set. And that is what we mean by the skewness of our data set. Okay, the kurtosis talk about the thickness of that particular distribution. Okay, a kurtosis of normal distribution is supposed to be 0. If your data set is normally spread, okay, or evenly spread, we say it is normally distributed, and the kurtosis will always give you 0 at the middle point. So we have an example of the summary of age here in this given data, and you have it in histogram. Recall that the histogram is used to present a continuous data, while our bar chart is used for categorical words. Bar chart and pie chart are used for categorical variables. Of course, the box plot is used for continuous variable, and that is the much we're going to take in this particular class. Join me again in research and statistics. My name again is Dr. Felix. Don't forget to like and subscribe to this particular channel. See you in the next class. Thanks for